Hello, everyone. I'm here today to talk about mobile applications with GWT, and I think it's a little bit awkward that we just heard the Internet Explorer commercial song right before that. I don't know if anyone noticed. But anyway, the talk's going to be split up in several parts. I'm going to talk about like 50 minutes why it's a very good idea to write mobile applications with GWT. I'm going to introduce you to PhoneGap and GWT for those of you who aren't GWT developers. By the way, who knows what GWT is? Okay, like almost everyone. Great. And I'm going to talk about two open source projects, GWT PhoneGap and mgwt. For those of you who don't know me, my name is Daniel. I'm a GWT developer since 2007, so pretty much from the start. And I'm also part of the GWT steering committee. That's the committee that drives GWT development together with Google. And in the GWT community, I'm somewhat famous for having developed two frameworks. The first one is mgwt, the other one is GWT PhoneGap. Those are all about writing great mobile applications with GWT. Before we get started, I just wanted to point out, I just draw a quick graph of your annoyance and the number of slides I'm going to use. And I think since we got like 50 minutes presentation with a little bit Q&A, it should be fine with 25 slides. I think we go like with 10 times more, just to give it a try. I've been a web developer for almost 15 years now, and that has founded one really deep belief in me, and that is mobile apps have to die. And that's a quite strange statement to make, because many people are actually making good money off of mobile apps. I'm making good money out of mobile apps. So I need like 5 minutes here to explain my point. And maybe you see it the same way I do. I'm somewhat the prototype of a geek, so if I'm interested in, say, something that drives, I just toy around and build it myself, even with one wheel. Or if I'm interested in electricity, I play around with it to learn something about it. And if I want to know something about physics, I just build something that can fly. This means I've done a lot of hardware in my career and way more software. And so 2007 has been a really, really great year for me, because as a geek, I really love to show off the stuff I've built, and it meant I could finally carry all the software I was doing with me in my pocket. That's really awesome. But soon, my phone started to look like this. Cluttered full of software, and I couldn't find anything anymore. Does anybody know how many applications you could actually carry around with you with the first iOS SDK? Oh, exactly. Someone may have heard the presentation before. The problem with that is I hit that like, I don't know, 2 weeks, 3 weeks after the iOS SDK got released, and I couldn't put any more applications on the phone. So Apple, they listened to me. No, they didn't listen to me. They decided that's a pretty good idea to introduce something called the folder concept, where you could finally like nest application into one another, and you could like carry around 1,684 applications with you. And my first impression was, whoa, that's really great, because that's like all the applications I'm going to need. And on second thought, I thought, no, that's not so great, because I couldn't find anything on my phone anymore. I was just constantly searching through the stuff. And then I took a look back at the web. And maybe some of you know this, but maybe you don't. But there's been a company called Yahoo. I don't know, nobody knows them anymore. And they had like a bunch of editors that actually were searching through the web and putting that web into a catalog like you used to know Yellow Pages. So users could search through that catalog and try to find something. Well, and then along came Google, and they did something different. Well, at first they said, there's no way with the number of growing web pages, actually people could search through those web pages and put them into the catalog. So they went ahead and just automated that stuff. But they did another important thing. They introduced ranking. So today, if you're doing a Google search, you're actually going to find something that's relevant to the search you just entered. And so they ended up with quite an amount of happy users and made a really big business. With that in mind, let's keep a look back into app stores. To me, app stores basically look like this. They're full of stuff that you might need, but I don't know. there isn't any real help in discovering the things you really want to have and the things you don't want to have. And it's going to get way, way worse. And why is that? Because it's not just about people like me who got too much software on their phones. It's about like normal people who are going to pay for their coffee with their phones, who are going to pay for their shopping with their phones, who are going to pay for their gas with their phones. And the expectation we can actually do, what we actually want to do with our software, are going to change. Let me give you one quick example. Today, what's really annoying, if you do a lot of traveling like me, you have to install a lot of different apps for doing that. So if you come to a bus stop, for instance, you really have to enter the name of the public transport company, search for that name in the App Store, you have to install the app just to find out when the next bus is coming. That's plainly wrong. And after that, you got all those applications on the phone. I got like applications from 20 different flying companies on my phone. I constantly have to delete them all over so I can find something. That's totally weird. And then there's some people who got it plainly wrong. If you go to some websites, they actually prompt you to install an app. They could just show you the content right away. No, you have to install an app. How would that work out? Like hundreds of small applications on your phone which you have to constantly update? I know what that should be. That should be a web page. You have to get a grasp of what's happening here if you talk to people who are doing actual hardware. And basically what they're telling you is it's so cheap to put computing into almost everything that we can actually do that. And pretty soon, this is going to be everywhere. And so this means the possibilities of what we're trying to do all around us is just going to be immense. Let's recap. I just told you that the number of things that we're trying to do with our phones is simply going to explode. Think of the amount of web pages that exploded in the late 90s, which founded Google. Of course, there are going to be some apps. Think of your desktop. You do have some apps installed, but there's only one pretty important application on your desktop that you cannot do without, and that's your browser. So it's not a question of if the mobile web is going to happen, it's more a question of when. So with that in mind, how could you write software today that takes these facts into account? And a pretty good idea to that is PhoneGap. I'm not going to introduce you how PhoneGap actually works. That's for later in the talk. I'm just going to try to introduce you how PhoneGap tries to solve that problem. So if you want to write software for those companies, like Apple, Samsung, and so on, you actually have to deal with all those different OSs. And then you have to deal with all those different languages and APIs. The problem with that is even if you're done dealing with all that stuff, they keep constantly changing. So with every major release, this goes all over again. And as a web developer, I think of this as a really, really big fail. Because we as web developers, we already have a very good way of bringing software to almost any platform without caring too much about the platform. And it's called the web. And PhoneGap is exactly about that. PhoneGap is bringing web standards to any device. If you want to introduce PhoneGap, you can mostly do it like this. So if you compare native and web development, what you're basically getting is if you're doing native development, high costs, because you have to learn all those APIs, you have to deal with all that stuff, you get high costs, you get low performance, low development times. You don't get any portability. Things you're building for Android, you cannot run on iOS, and vice versa. You're getting good performance here. You can access all the native functionality, let's say like a contact, like the contacts or an address book, the file system, and so on. And you can be in any app store. That's great. On the other hand, if you're doing web development, you get good development times, you get low costs, because you got lots of web developers out there who know how to write good software. You get high portability. Things you're building for the Android browser probably run on the iOS browser. You get good performance if you know what you're doing. Some HTML frameworks fall short here. I'm going to be talking a lot about performance later in the talk, so if you're doing things right, you get really, really good performance. But you cannot access any native functionality, and you can't certainly be in any app store. This changes as soon as you put PhoneGap into the mix. Because with PhoneGap, you're a native application and a web application at the same time. So you're getting the best of both worlds. And with PhoneGap, there's one really big promise in the room, that is, build your stuff once. wrap PhoneGap around as a container, and run it everywhere. And running it everywhere really means running it everywhere. So across all those different platforms like iOS, Android, BlackBerry, WebOS, Symbian, Tizen, Bada, and so on, you get a consistent APIs for accessing the device features, let's say like an accelerometer or the camera. And that's the basic problem PhoneGap tries to solve. Bring a consistent API to all those different devices based on web standards. So now we can access native functionality. What about writing good, really good HTML5 applications? And that's where GWT comes in. For those of you who don't know GWT, it's a very cool way of writing JavaScript applications in Java, which may sound like a crazy idea at first, but it's a very good idea because you can reuse all the Java ecosystem for writing really good browser applications. Think of your IDE or, let's say, bug finding software. And you can do everything in Java. Well, you don't want to have to use this to install some kind of plugin, so we just compile down to JavaScript. And there's a very clever compiler in there, which is very concerned about performance, and which is very, very good at optimizing. So what you're getting out there is very, very fast JavaScript. And that's actually quite important for mobile, because on mobile you got those slow CPUs. You got those slow network connections. You're running on batteries, so even if you have a fast CPU, you cannot use it all the time. Otherwise, you're just going to drain the user's battery. So this is why GWT is an optimal fit for writing mobile applications, because it optimizes for you without you caring too much about all the clunky details underneath the covers. Unfortunately, if you want to use PhoneGap and GWT together, there's some key parts missing. And that's what mgwt and GWT PhoneGap are all about. mgwt is about great-looking mobile widgets, which are cross-platform. And GWT PhoneGap is about accessing PhoneGap from GWT directly from Java. Both projects are open source. They are under Apache 2.0 license. And they're a very, very cool way of writing HTML5 applications, which you can then take and put them into any app store using PhoneGap. But you can also deploy them to any web server. And that means that you can give people an actual choice. So if you're like me, you're traveling too much, and you get in front of a bus stop, you can actually just, let's say, put in a QR code with a mobile web page, and you can get the information right away. That's way, way better. So cranky people like me, who got too much software on their phone and constantly have to garbage collect their phone by hand, you're going to turn them into happy users. So that's the idea why I'm standing here. We need a better approach. Mobile applications are just not going to cut it. Imagine if you fill out a Google search query. For every search query, when you click on a link, you have to install an application, and you click back, you have to deinstall an application. That wouldn't work, and it won't work on mobile either. So what's the technology stack in getting around this? So if you want to write a web application, basically what you're going to do, you're going to have to deal with the device, with its browser. On top of that, you're going to use some mgwt for great-looking UI, and you're going to write some glue code for triggering that UI. As soon as you want to build an app that's going to be deployed into a store, you're just going to add PhoneGap. So PhoneGap has a native part and a JavaScript part, and GWT PhoneGap on top to accessing all that greatness. So let me introduce you on how PhoneGap actually works. Every PhoneGap application has two parts, as I said before. It got a web part and a native part. On the web part, you got a so-called native web control. And inside, you're just going to put all your HTML, CSS, and JavaScript. So if you know how to write good web applications, you already know how to use PhoneGap. On the other side, you got so-called PhoneGap plugins. Don't confuse them with browser plugins. That's not the same. It's just called plugins here. Excuse me. So this is just native code. So on Android, it's going to be Java code. On iOS, it's going to be Objective-C code, and so on. And what we also need, we need some communication between the two parts. And this is the foreign function interface. And let's quickly go through all those parts. So the native web control, as I said before, that's just a browser, right? Really just a browser. Just a full-screen browser without any Chrome to it. And on most of the platforms, it's just the platform browser. So on mobile, on iOS, you're getting something like WebKit, WebCore with JavaScript core underneath. On Android, you're getting WebKit. On BlackBerry, you're getting WebKit. On WebOS, you're getting WebKit. On Symbian, you're getting WebKit. And there's just one company who doesn't get it. So basically, if you know how to write software for a great browser, you're almost there. So let's take a look on how the foreign function interface actually works. This is under the covers. You don't actually have to deal with that, but you should know how it actually works under the covers so you don't do stupid things. Let's say you want to shoot a picture in a PhoneGap application. This is something you could not do as a web application right now. So they introduce an API for that. As soon as you include the Cordova.js file, you get a camera object on your navigator object. So you can say something like navigator.camera.getPicture and pass in two functions. One success function if the picture is taken successfully, one fail function if something went wrong, and some options here. Internally, Cordova does something like this. It calls Cordova.access, passes in those two functions, and resolves the so-called native plugin, in our case camera with the action take picture. And it passes those options into an array of options. So this is different on every platform, but it used to work like this on iOS. It's just about the basic idea. Now it builds up an URL. It starts with gap. Then there's the plugin and the action on the plugin. Then there's a so-called callback ID and the options URL encoded. And now it takes that URL and puts it into a hidden iframe, which from a web perspective doesn't make any sense whatsoever. But as soon as you do that, the native code can see that navigation and immediately cancels it. But while seeing the navigation, it also sees the URL. So it now can figure out what it actually needs to do. Okay, I'm seeing this string. Well, I need to call the camera plugin with the action take picture and pass back the options. So it just now triggers some native code which does something. And as soon as it's done, it calls back into JavaScript saying, okay, I've done that successfully. Here's your callback ID, and here's the data you wanted. With that callback ID, we're actually going to find back our two JavaScript functions. In that case, we're going to take the success function and just execute, and you get the picture back. So if you're using this, there are two important things to remember. All the data you're using has to be encoded into strings. So it's not the fastest way of doing that. So let's say if you want to upload a file to a web server, you're actually going to do that just in native code and just dispatch progress to the website. The other thing is, all those APIs are asynchronous, meaning that you can do actual synchronous calls with this approach. On some platform, let's say on Android, that works. But if you want to be real platform cross-compatible, you have to do asynchronous APIs, which is absolutely fine for web developers. So that's a good overview of the web part and the foreign function interface. Let's talk quickly about the native part. On the native part, we got many plugins coming right bundled with PhoneGap. So almost anything you're going to need is just inside the open source project. But you can build any plugin that you like yourself with the same approach. You can just call Cordova.access on the JavaScript side and get the data. On the native side, just reply with some data. So you can build anything a native app can do. But before you start doing that, there are lots of high-quality plugins already out there. Check them out before you do anything. What really caught my eye on PhoneGap 3 years back was the fact on how they actually treat themselves. And PhoneGap, for those APIs, uses W3C standards where possible. This is a very good approach. And why is that? Because let me give you a quick example. They introduced a way of getting your geolocation the same way the W3C did the specs back in 2008, I guess. Not sure, maybe it was 2009. There was no way to get the geolocation within a browser controller on iOS. So they just introduced that API using the approach I just told you. And when Apple finally decided that it's okay to get the geolocation within the browser, they used the same API because it was the W3C spec. So PhoneGap can just remove the implementation without you doing anything to your code. So in a way, you can think of PhoneGap as a time machine for web developers. We can now have all the cool features that only native developers can have right now. So PhoneGap thinks of itself as an intermediate, as something that has to go away and has to die when the mobile web is finally there. And that's PhoneGap. And I don't know, there are not many open source projects, I guess, that actually think of themselves as something that has to die. That's PhoneGap in a nutshell. Let's talk a little bit about GWT. As I said before, probably with the Java conference I can skip through most of them. Just some basic things here. GWT actually offers you to write JavaScript applications in Java. It's a completely client-side framework, so you don't have to deal with any special server whatsoever. You just compile everything down to JavaScript. But while developing, you can do everything in Java, which is a very, very good idea. We're going to come to that in a second. But it doesn't have to do anything with Swing or whatsoever. So you actually have to learn how a browser works for writing good GWT applications. But if we are still developing, we got something called dev mode. And in dev mode, we actually do have a browser plugin, which captures all the interaction and dispatches them to your IDE, so you can actually just debug your browser application line by line, like you would debug a normal JavaScript application. But we don't want your users to install a plugin, so we do have to have a compiler, of course. And that compiler takes all your Java code and compiles that down to JavaScript. It actually compiles one JavaScript per browser, which is a very good idea if you think about it. We're going to come back to that later. As a rule of thumb, if you have like 100 lines of JavaScript in your code, you're better off coding by hand. But after that, with GWT, we are better in execution speed and size. Because we can do several things like dead code removal, inlining, renaming, zipping, secure caching that works, and so on and so forth, that are really, really hard to do in plain JavaScript. Let me give you one example of the kind of optimizations we can actually do. Let's say we have some shapes, like a circle. So circle extends shape. And we want to actually get the amount of space that circle occupies. So in Java, you could write some code like that. Construct a circle and save the variable in the shape, and then actually call getArea on shape, which is a virtual function, which is going to be an abstract function, which actually has to call the circle. The compiler takes a look at this, and because of static typing, it can actually figure out that S can only be of type circle at that point. So it can find the right function to inline. So you can do something like type tiling and say, okay, S is only circle S, and it can put the right function there. And now it can take another look and say, okay, math.pi, that's a constant. What if I would know the value of radius? I could just inline the value, and at that point of execution, it actually knows the value. It's 2. We can all see that. So that's what ends up in the code. And now imagine that kind of optimizations across a big JavaScript application. We got something other that's really cool. It's called deferred binding. For a Java programmer, it's something like reflection at runtime. With JavaScript frameworks, you get a lot like if Internet Explorer do that, else if Firefox do that, else if Safari do that. And what we're actually doing is we're just providing one interface for you to call, and we're providing all those different implementations. And at compile time, the compiler can just swap out the implementations. This is why we compile once per browser, so you don't get getting any if-else at runtime. But GWT isn't a framework where you just do GWT and nothing else. It's designed from the ground up to run together with JavaScript. So you can just, in your Java IDE, hack some JavaScript in there as well. I'm using that a lot to get GWT PhoneGap working, of course, because this means calling a JavaScript API. The next slide is quite cool. Don't look too much at the actual numbers because the slide is somewhere from 2008. But what you're seeing here is the compiled script size against the number of widgets you're using. You can see an empty application is quite small. A hello world is about 5K, which is huge. And as soon as you add the first real widget, like a vertical panel, you're going to see like 25K here. That's not so great. But see what happens now. As soon as you add a button, you're just going to grow slightly, because button and vertical panel actually share a lot of code. And the compiler can optimize on that. What you're seeing, the more stuff you're adding, the less you're growing, which is something you really want to have for big applications. And think back on mobile. We talked about this. On mobile, performance is way more important than it is on desktop because of the slow CPUs, the slow network connections. We're running on battery. And so this is a very, very good fit. GWT optimizes that stuff for us. So this is GWT. Let's talk about GWT PhoneGap. And GWT PhoneGap gives you access to all those device APIs like the accelerometer, the camera, the compass, contacts, the file system, geolocation, media, storage, and many more things directly from Java. You're guessing I'm trying to make up slides now. All directly from Java. It's under Apache 2.0 license, but we can do more. Because of deferred binding, think of dev mode. In dev mode, you don't have a device around you. You just want to be developing in the browser with a high turnaround time. You don't want to actually be on a mobile device all the time. So what we can actually do, we can just emulate the whole PhoneGap API for you without any runtime penalties. So basically, we have an interface, that's the PhoneGap API, and we have two implementations. One you're going to take for the compiler if you actually compile for a phone, the other one if you're just developing inside the browser. We can mock the whole API just for you. That's pretty neat. But let's talk about the stuff I really care about, and that's mgwt. mgwt is all about writing great mobile applications with GWT. So it has a lot of stuff in there, like touch support, mobile widgets, editor support, UI binder support, fast and great looking animations, and so on and so forth. It does support all the important mobile browsers. You guessed it, right now no Internet Explorer in there. But what I want to do is give you an impression on how it actually looks. So let's take a look at a few screenshots. And since this is cross-platform, we are actually looking different on every platform. You can style it to look like you want to have it to look, but if you don't do anything to it, this is what it looks like on an iPhone. So no surprises here, it looks like a native application with different widgets you could use, input elements, let's say progress bars, different dialogues, just input elements, search boxes, sliders, or a tab bar. But a cross-platform thing really gets going as soon as you go to the second platform. Let's say if you have an iPad. Because you can take the same application, style it a little bit different, and do a little bit of different layout, and you got it running on an iPad with all the different widgets that are in there with mgwt. I'm going to just click really fast through them. But it gets even cooler with a third platform, let's say like an Android phone. I'm not going to do that for every platform, but I want to give you a quick impression. This is what it looks like on an Android device with all the different widgets, dialogues, progress bars, even pull to refresh widgets. Scrollers, I don't know, I missed one. Search box, the slider, a tab bar. There's actually so much stuff in there that I'm not going to cover that in 20 minutes. No chance here. But I want to give you a few things which you might consider even if you're not using mgwt, if you're just doing mobile development with HTML5. You really have to think about performance. And I care deeply about performance because if you don't have good performance, you don't have an application. And there are different kinds of performances. Well, there's of course startup performance. Then there's runtime performance, and of course resource usage. And I want to talk about startup performance at first. We're going to come back to runtime performance later. And startup performance is hugely due to downloading stuff, evaluating, so parsing stuff, and actually executing something. And the bad news here is you have to actually download everything, so you're getting latency and transfer time once per file. So bigger is not always better. It's quite the opposite. If you have a slow network connection, which you have in Europe in many situations, let's say you have I don't know, an edge connection with 4 kilobytes and 5 seconds latency. That's a decent thing. That's high latency, low transfer rate. You really have to care about all that stuff to get your application down to the user and actually getting it to display. If you're doing one of those things not just right, you're going to have a ruined startup time. So you have to really care about your HTTP request. Are you doing asynchronous loading, or do you have blocking script tags in there? Are your HTTP headers right? Are you caching all the resources that you can probably cache? Are you doing offline support, HTTP batching for your data, and so on and so forth? Are you doing minification of all your resources, script inlining, zipping of the resources? Are you doing code splitting, so bringing down a small amount of the application first and actually downloading the rest in the background while the user is already using your application? What are you doing to enhance your parsing? So parsing and actually building the rendering tree is going to get fast. And with JavaScript development, basically it works like this. You're dropping in some kind of libraries with some CSS. Then you get add some JavaScript on top of that with some CSS and some resources. And later on in the process, you're wondering on how to actually get that fast down to the client. And basically, you're on your own. There's some tools to help you with that, but it's a really, really hard process on doing something like that. And this is why, if you actually take a look at high traffic websites, which most of them actually use some key points here. So if you're concerned about mobile performance, you should definitely think about an optimizing compiler. Because it got all the knowledge of what you need to do just inside the compiler, and you can just care about writing your application code. You don't have to deal with all that stuff all over again. And with GWT, development is different. We don't do like separate CSS and separate JavaScript. What we do is we write up resources. Of course, we're using CSS, but the CSS is known to the compiler. The Java code is known to the compiler and the resources as well. And it just produces one big output for us. And on that big output, we can actually enable perfect caching. So no worries about some clients getting older versions if they're not supposed to, and the other way around. But because we can see all the output, you can actually tell us where we need to split up the output, so we can download a small chunk at first, while the other big chunk is downloading in the background, so users can already use the application. With HTML5, you can actually do better. You can store your web application right on a phone, so you can they can be used offline, so while sitting in a plane, for instance. Some people in the JavaScript community are actually writing articles on how app cache, that's the API that's doing that, is a douchebag. Offline support with GWT is quite easy because we're sealing all the resources, we're compiling them for you. We're just generating a manifest file for you, and this means once the application is downloaded, there's not going to be any download whatsoever. So app cache is quite easy to use with GWT. It's 2 lines of XML. So keep in mind, bigger is not always better. Really care about the size of your resources. And if you compare mgwt to other JavaScript frameworks, you're going to discover that we are very, very small in size. And that's due to many different facts. If you want to have really good applications, you have to do a lot of good choices. And I think we've done a fair amount of good choices. And one of those, I want to introduce you to some of those choices. And one of those choices is actually, in this screenshot, there's no image. This is just CSS. Even the back button with the pointy stuff, this can all be done with CSS3. So imagine the difference, excuse me, imagine the difference between actually downloading a background or just having a small string in your CSS that actually builds that background. That's a huge amount and it adds up. The other thing you have to care about is your markup. You have to use minimal markup. And the slider you're seeing there, that's the markup for the slider, is actually one of our biggest widgets. It's like the worst case. But what you want to do is basically use one div for a button up there. And what we can actually do, because we're seeing your CSS, we can actually rename your classes for a production compile. This means that the matching between the DOM and the CSS tree that builds the render tree inside the browser is way, way faster. And we're actually saving bytes and downloading here because your classes are going to get smaller. But the main thing we can do, which makes us so small, is dead code removal. And I can talk like all day about this, but I want to give you one brief example. Take a look at those 2 sliders. This is a slider from Android, and the other one is from iOS. From the iPhone, sorry. They, of course, share some code for moving that pointer around. But they don't share that much code in styling. So what we really want to have is like trying to have the compiler figure out what kind of the styling and the code actually needs to go to which device. So we compile once per device, meaning we produce one permutation of JavaScript once per device. This means that only the code that's relevant to a specific device ends up on that device. So if you're only using 20% of mgwt, you're not going to get punished for using mgwt. Only those 20% end up in your actual compile. And that's down to fields and even methods. And GWT does excellent work at that. If you want to get a good grasp, if you're using a GWT application, on what's actually ending up inside your output and what's not, the story of your compile is your friend. And we use that heavily to make sure that all the stuff that actually can be compiled out, if you're not using it, can be compiled out, even with CSS. This is why we're using CSS resources for mgwt themes. They look great out of the box. They can be easily customizable, but you have to have that special GWT syntax to them. And actually, if you're just getting started, there are a lot of different themes for the iPhone, iPad, Android tablets, and so on and so forth. There are always people that are talking about JavaScript performance. And I want to show you a few key points if you're thinking about performance on mobile. That's actually not that important. Because there are different ways of what the browser actually does, and most of them are not concerned about JavaScript performance. So this is a decent-sized mgwt application. Here are the numbers for actually getting it up to start. It's not about download, it's about if you have all the resources locally, how you can actually start up the application. You can see there's some time for parsing, which is like 10 milliseconds on an iPhone. Then there's some for actually executing JavaScript, which is about 60 milliseconds on an iPhone. But the most amount, if you set up your DOM, if you set up your CSS and everything is just right, the browser needs some time for painting. So if you want to improve mobile web even further, you have to improve painting in the rendering engine. It's not so much about actual JavaScript performance. And this leads us to runtime performance. So if you want to have good runtime performance, think about what you're actually doing. And one of the key things that your application really feels snappy and really is responsive is your layout. Some JavaScript frameworks choose to do their layout in JavaScript, which goes a little bit like this. They have somewhere in the code, they have a resize listener. So if you turn the phone or if you resize your browser window, that fires. Then they start some calculations in JavaScript. They're going to update the DOM with that calculations. And then the browser does its magic and actually prints that to the display. The problem with that is all that is running in JavaScript, which is a very, very bad idea. Because if you want to have really, really fast layouts, there's one thing you need to do as a web application, that is never leave native code. And that's a very strange statement to make for a web developer, because frankly, we are never writing native code. Well, in a way, we are. If you're doing all your layout in CSS, you're using the C code of the layout engine to do the layout for you. So basically, you're just configuring the layout engine. And with HTML5, there are all the features to do your complete layout just in CSS. And if you don't know about the flexible box model, you should definitely check it out, because it's like everything a CSS developer has ever dreamed for. We use that very, very heavily and rely on that. So our layout is very fast and very responsive. And I can actually tell you a quick test on how to find out if something is built with CSS purely or if they have some JavaScript involved as well. If you take a phone and you actually turn the phone, and you can see the phone layouting while turning, this means the layout engine knows all about the layout because he can do that while turning. The layout listener that's in JavaScript, that only fires after the phone has turned. So you can basically turn the phone and you can see it computing, and you can see like resizing something. That's pretty bad. The other thing you want to get right in runtime performance is your animations. They should feel the same, they should look the same like native animations. And some animate it a little bit like this. They build up a loop with set timeout in JavaScript and periodically just update the DOM, which is going to update the display. Let's say if you want to move a div from here to there, basically what you're telling the browser here is move it 1 pixel, move it 1 pixel, move it 1 pixel. There's no way he can optimize on that. He can just redraw the screen every time, which is very expensive. Just trigger layout and redraw. So don't do that. Do it like I just said. Hey, I want to move that div from here to there in 300 milliseconds with that timing function. And you can actually do that just with CSS. So basically, you're putting in some CSS. You can like compose that on the fly, or if you know the animation while compiling, you just going to put that in your CSS as well. Put that into the DOM, and from there on out, the browser can figure out a decent way to do that. And most of the time, on many platforms, this is actually GPU accelerated. I can maybe, I don't know if you're running, no, we're only good on time. I can show you an example on such an animation running, and it actually uses the same routine that it would do on native iOS. So this has the same performance. It doesn't drain the battery because the JavaScript VM doesn't have to even run for the animation to update. So this is animations. That's pretty important to runtime performance. Let me recap. I started off by telling you that maybe building mobile applications the native way isn't such a good idea. Because the amount of things we're going to do with our phones is just going to be overwhelming, like the amount of web pages grew up in the late 90s. So there's no way of us installing applications to our phones for doing everything. Imagine you have an application for actually controlling your TV in the living room, but right now I don't really care about that application. It's just going to be my way. But maybe I care about other applications right now. And eventually the mobile web is going to cut it. It's just a matter of when. And you actually want to be able to build things once. You don't want to build them all over for all the different platforms that are emerging. Nobody can tell you which is like the successing platform like we had with Windows on the desktop. You're just going to have like many different platforms coming up. And PhoneGap is actually a very good way of staying out of that platform war. You don't really care about the platform, all you're caring about is HTML5 standards, which is a very safe bet because no hardware vendor can afford to bring a new tablet, phone, or whatsoever to the market which cannot display current web pages. Think about it. There's no way that you can display like an application that's 15 years old with a current tablet, or even 10 years old. But there's a high chance that you can actually take a look at a website that's 10 years old and the modern browsers still render those web pages. That's pretty awesome. So it's a pretty safe bet. But if you're doing that, you have to do things right. You have to learn about the web as a platform and what's actually right. And there are tools with that can actually greatly help you. That's GWT and, of course, mgwt, which cares deeply about performance and has a lot of great-looking UI to it. So all this is done with performance from the ground up. So if you're interested in hearing more about all that stuff, you might want to check out m-gwt.com. This is where all the open source stuff is pulled together. You might also want to follow me on Twitter or take a look at the user group, which is very viable right now. What I actually want to do now is like show you the stuff running on a real device and actually open up for Q&A as well. So let me quickly change projectors here. Hey, that worked out great. So what you're seeing here is just my iPhone. I just open up an application here, and that's an actual application that's running on App Engine, done with mgwt. So you got all the different stuff in here that you might expect from a normal application. You can take the same application, just put it to the home screen, and just show it there. So it basically looks like a full screen application. So you got things like animations in there, which are just purely done with CSS. You can animate in any way, but there's just some demos in here. You can do anything you like to do. So let me quickly go through those. You have many different things in the UI here. But there's one thing I just told you. You can actually see if something is done with CSS while layouting while turning a phone. You can actually see it layouting while turning. You can take a look at many other different frameworks which don't do that. So let's see. So we do have carousels in here where you can just scroll content. We do have different elements. And here's something I wanted to show you. This is an animation purely done just with CSS. So I can like put my iPhone on the table and let it animate for hours without draining the battery, because all this is done just on the GPU, not on the CPU. So you're going to have like many different widgets in here. Actually take the same application on an iPad, it just looks differently. You can check it out yourself, m-gwt.com, there's the showcase. What I also wanted to show, you can take like an mgwt application actually hosted inside a PhoneGap application. This is what this is about. This is just a demo application for accessing all the PhoneGap API. So you can just take a look at the accelerometer, say I want to have those values, and you can actually see them coming in live. So while I turn the phone, you can actually see the values changing. But you can do also integration with real native code. Let's say if you want to take a picture, the code I just had on the slides. We're still in the web part here. I can go back and forth as I like. I can choose to take a picture. And now we're going into native code. This is actually a native view coming up here for taking the picture. So smart, everyone. We're going to take that picture, say, okay, I like that picture, just use it. And like that, we're back inside the web application. We just took a picture from a web application. So you can basically use the same application, deploy it on a web server, and just reduce your features a little. And if people are willing to install it, you can actually just let them install it through a normal app store. So that cuts it for demos. I think we got about 10 more minutes for questions. So please feel free. Yeah, please. A little bit louder. Is it possible to create what?
Android launcher widget on the Android on screen.
Is it, well, with PhoneGap, you're just a native application, so you can host it. Oh, sorry. The question was if you can create, what's that? Widgets, of course. If you can create widgets for Android. And the Android web view, you just saw that browser, it's just embeddable to everything. By default, you're going to write an application based on an activity, but you just need to change a few things in your code. You can actually bring that to the home screen as a widget as well. That wouldn't work, yeah. That would work, of course. Yeah, please.
So Mark Zuckerberg recently said that HTML5 is the biggest mistake he made. Let's see, real mistake.
Okay, the question is, Mark Zuckerberg recently said that HTML5 was the biggest mistake Facebook made, and if their real mistake was not using mgwt. Well, it's kind of a twofold question. If you actually take a number at Facebook, if you take a look at Facebook, they actually have more traffic to the mobile website than they have combined with Android and iOS together. So they care way more about mobile than they care about native. That said, they have a very complex requirement in rendering that timeline, which is way, way more than most people have. The problem with that is they don't get access on how much memory they're actually using. So if they have like hundreds of entries which they need to render, well, it's going to be difficult. That said, I don't know what they actually did, but I heard some weird rumors about them actually not using the browser very well, and it might as well be that it might be possible to do that. But maybe some edge cases are still need to be done natively. But I think that's set for Facebook. I don't want to be rude here, but I think probably it's going to be okay doing that if you take the browser into full account. Any more questions? Yeah, please. The star is, the question was, what was the little star on the performance sheet? Well, if you're going to treat the browser like a desktop client, if you're going to do your layout in JavaScript, if you're going to not use CSS for that, you're going to have bad performance. And people are actually thinking of HTML5 as something that has to have bad performance. But think about this. Having an optimized browser is sometimes more important to Apple or to Google than having a fast runtime, because people are always caring about web browsing. So on some Android devices, if you're doing things properly, you're much faster than native applications are. So you really have to deal with a browser. You have to learn on how a browser actually works internally to leverage its full power. But especially on mobile, they have to have like really advanced browsers because they don't have that big CPUs. So you have to use those features in order to get fast. This is what the star was all about. Okay, more questions? Oh, please. My opinion about the HTML5 canvas, it highly depends on the platform you're talking about. On iOS, it works great. We have had an application that actually needed to draw documents from the back end to a canvas. And on iOS, you wouldn't tell the difference between the native application scrolling through a PDF or the canvas application just scrolling through PNG files that we downloaded from a server. On some Android browsers, this is a totally different story. It behaves weird on some Android browsers. But those devices are going to get away from the market pretty soon, and it's going to get better. So it's not going to say about there's some hiccups in some Android devices. Sometimes the Android browser is not that great, but most of the time it's actually a very good way.
Any plans to include it inside the framework?
What to include inside the framework?
Libraries that will assist us to use Canvas efficiently.
Well, we can talk about that. The question was, is there any plan to include Canvas APIs into mgwt? And there's actually Canvas API for GWT, which we are using, which is fine for us. If you have other requirements, we can certainly talk about them. Maybe there's something we could improve. Yeah. Questions? Yeah, please.
Can you comment on the Dart project? How do you see that?
How? Well, I'm not working for Google, so I cannot comment on what they're doing with Dart. The question is, are they going to continue building GWT, moreover? And Google said before in Google I/O, Ray Cromwell gave the talk and said, well, we are heavily invested with GWT. We have so many applications at Google that are running on GWT, there's no way we could even quit it. So all those rumors that happened around Dart is going to replace GWT, there's nothing behind that, nothing. So Google can afford to do many, many projects, and Dart is one of them. But GWT is going to be there for a long time, and we actually just made one of the biggest releases ever with GWT 2.5, so it's going to be there for quite a amount of time. I don't know if you checked it out, but we actually did improvements that some of the applications you're building have a 40% reduction in size. So there's a lot of investment going on there. It's not made that publicly right now, but, well, we're doing a lot. And actually with the steering committee, we're doing a lot in getting all the source code and everything out of Google, so we can finally have that out in the open. And we actually have managed to get all the GWT source code out on a Git repository, so you can check that out from there and actually push back to us and get into the code review system. That's live for 2 or 3 weeks now. And I've actually contributed that way as well. Yes, please.
I've seen this big survey regarding the future of user space.
The question is, what about the GWT survey we did recently? And the GWT survey, we had about 1,400 people actually taking part, which is a good sample number. And there were some amazing numbers in there. And I'm not supposed to talk about the survey yet, but we're going to release all that data out in the open in 1 or 2 weeks. So you just have to wait a little. But let me give you one thing, that most people who took part in the survey are actually writing applications that are between 2 and 10 megabytes or even larger in JavaScript size. So GWT is mostly used within the enterprise with really, really big applications, where you really care about all that optimizing stuff, because otherwise the browser wouldn't be able to execute what you're trying with it. But it's going to be out in 1 or 2 weeks, so just stay tuned. Yes, please. The question was how, with native applications, we can control the permissions that the application has. And how can we do that with PhoneGap? Well, with PhoneGap, you're just going to be a native application the same way. So you're going to do that with the Android manifest file. So if you're doing PhoneGap development, there are 2 ways of doing it. If you don't care about building the native part, you can just push your code to build.phonegap.com, and they actually give you back the APK file. So you don't have to install the SDK if you don't want to do that. If you want to write native code yourself, if you know how to do that, well, you can build locally, and you have a normal app. Just within the app, there's going to be your HTML, CSS, and JavaScript. And that's it. Yes, please.
Yes, but if you have multiple PhoneGap apps, they will all have the same permissions.
No. The question was, if you have multiple applications that are built with PhoneGap, do they have the same permissions? No, it's an individual app all over with different manifest files which you compile differently. So you're going to end up having the PhoneGap runtime several times on your phone. Well, some hardware vendors are actually working together with the PhoneGap project and bringing PhoneGap as a first-class citizens to their platforms. The new BB10, which is going to be released in January, actually has a PhoneGap container on board, so you don't need to have include special APIs for that. And the new platform from Intel, Tizen, already has a PhoneGap container right built into the tablet. So PhoneGap is making a really big impression on the hardware vendors. Yes, please.
You sound quite confident that web client apps will replace the native apps. What we are seeing is completely the opposite at the moment. Why is that, and how does it change?
Okay, the question is, I'm pretty confident in that mobile web is going to succeed, and you're saying you're seeing quite the opposite with your customers. Well, it's going to be a while. It's going to be the same for a while. So basically what we do with our customers, we just build stuff once using PhoneGap and give them a native application if they want to. If you do have customers that don't care about the native, don't care about web applications, well, they're paying. So what you're going to do? But we discovered that most of the people are just saying, okay, we need to have applications because everyone else is doing applications. And as soon as you show them the possibilities of having linkable stuff within their IT infrastructure, they decide to actually go into the web even more. They don't care about. They actually are pretty much okay with this add to home screen workaround right now. So you have the application on the home screen as well, because they like the fast turnarounds, which you can actually update without any stores in between and so on. It's a little bit about communicating, because right now they are not thinking that mobile applications can do that, but if you're showing them that what can actually be done on mobile web, they're going to discover that for most business cases, pulling some data and displaying it is absolutely fine. So I think we're running out of time, aren't we? Yeah, I think so. So thank you all.